Welcome to episode 8, 3 segments, securing the skies, powering drones, and defending America with U.S. battery manufacturing. Welcome to the Watt Hour. This segment will be speaking about powering the space economy with American Energy. Welcome to the Watt Hour. I'm William Hadala, Vice President at American Lithium Energy. In this episode, I want to share a perspective I believe is shaping the future, not just of aerospace, but of how we think about energy, resilience, and industrial leadership. The space economy is growing at an unprecedented rate, now estimated to be over $600 billion globally. That's not just a number, it's a signal. A signal that we're entering a new era where what powers our platforms is just as important as the platforms themselves. This momentum didn't happen by accident. It's the result of sustained investment from governments, the rise of commercial space ventures, and a renewed commitment to innovation. Across communications, defense, observation, and transportation, we're seeing a renaissance in space infrastructure. But as someone working at the intersection of energy and aerospace, I can tell you this. Behind every breakthrough satellite or spacecraft is a quiet but essential foundation: power. If we don't address the quality, availability, and origin of that power, we risk building the future on an unstable base. There's a growing realization among platform developers and integrators. You can't scale the space economy on legacy supply chains. Most battery cells still come from overseas. That means long lead times, inconsistent performance, and serious risk exposure. For companies working in high-value applications where uptime, safety, and trust are non-negotiable, that's not acceptable anymore. This is where a shift is needed. From outsourced energy to domestically engineered, mission-aligned power systems. Because no matter how fast we innovate above the atmosphere, it all fails without dependable energy beneath it. At American Lithium Energy, we've spent the last decade developing battery technologies for the most extreme environments, space included. Our lithium-ion cells are built for low Earth orbit and deep space applications, ISR drones, and autonomous satellite platforms, zero failure mission profiles with high discharge rates and thermal resilience. We deliver energy densities up to 350 watt-hour per kilogram, safety tech like SafeCore and Zero Volt, and proven reliability across wide temperature extremes. And we build it all in the United States from R&D to production. This isn't off-the-shelf energy. It's engineered for defense, aerospace, and systems that can't afford compromise. The space economy's growth is real, but sustaining it will depend on more than satellite launches and capital investment. It will depend on whether the energy systems behind it are trusted, scalable, and secure. This is a moment for OEMs, platform designers, and systems engineers to ask, is our power solution built for this decade or the last? At American Lithium Energy, we're not just building batteries. We're helping build the industrial backbone that keeps America at the forefront of space innovation. I'm William Hadala. Thanks for watching the Watt Hour. If this resonates with your mission, let's have a conversation, because when we talk about powering the future, we mean it literally. Welcome to the Watt Hour. This segment will speak about powering the drone future. Welcome to the Watt Hour. I'm William Hadala, Vice President at American Lithium Energy. Today I want to talk about a major transformation happening across aerospace and defense, one that's redefining how we think about autonomy, readiness, and energy. Uncrewed aerial systems, UAVs, are no longer an edge case. They're core to the future of defense and commercial strategy alike. But beneath the hype around autonomy lies a fundamental question that still isn't getting enough attention. What powers these systems? We're seeing an ecosystem emerge that includes everything from Group 1 tactical drones to Group 5 long-range ISR platforms. Add to that collaborative combat aircraft, swarming systems, autonomous maritime, and ground platforms, and it's clear that autonomy is scaling fast. But here's the challenge. While autonomy evolves through sensors and algorithms, mobility is still powered by the battery pack. You can't fly, fight, or surveil with software alone. If energy isn't part of your platform strategy, your autonomy roadmap is incomplete. In conversations I've had with drone OEMs, defense primes, and integration teams, one theme keeps resurfacing. Energy is often the weakest link. Too many platforms still rely on foreign-made cells that were never engineered for these missions. That means uncertain availability, unknown thermal profiles, limited discharge rates, and vulnerabilities we can't afford in contested environments. We've reached the point where supply chain resilience and mission assurance must start at the cell level. Power is not a commodity, it's critical infrastructure. At American Lithium Energy, we've built our battery technology to solve this exact problem. Our cells are engineered and manufactured in the United States with performance characteristics that match the mission profiles of today's most advanced UAVs and autonomous platforms. Energy cells rated up to 350 watt-hour per kilogram. Power cells that support 20C to 100C discharge, operational from minus 40 degrees Celsius to plus 70 degrees C, built-in zero-volt technology for long-term storage, integrated safe core TM fuse tech for thermal protection. Whether you're building VTOL drones, ISR platforms, loitering munitions, or command and control nodes, our energy systems are designed to support your platform's purpose, not limit it. We're at a strategic inflection point. Autonomy is no longer theoretical, it's operational. But the real differentiator will be in the infrastructure we choose to build it on. So if you're an OEM integrator or government leader asking, how do we ensure these systems are reliable, secure, and ready for scale? Start with the battery. Start with a partner who builds in America. Start with American Lithium Energy. I'm William Hadala, and this is the Watt Hour. If your mission requires power that performs, we're ready when you are.
In this episode, we'll speak about why national defense strategies must include American battery manufacturing.
Welcome back to the Watt Hour. I'm William Hadala, Vice President at American Lithium Energy. Today, I want to share a perspective not on a single headline, but on a strategic pattern I believe we all need to pay attention to. There's a clear acceleration happening in long-range deterrent platforms like advanced bombers and next-generation missile systems. And right at the heart of that shift is a question we're passionate about: where is the power coming from? Voiceover with animated graphics or clean visuals of aerospace systems. For years, the Department of Defense and its ecosystem of contractors have worked to modernize platforms that are fundamental to deterrence. Programs like the B-21 Raider and new generation ground-based systems are reshaping what capability means in a contested environment. What I find compelling isn't just that these platforms are advancing, it's how quickly the defense ecosystem is moving to adopt new energy expectations. These are systems that demand secure, scalable, and domestically sourced energy, and that's where the opportunity lies. Let's talk about that gap. Many of today's defense systems still depend on foreign-made batteries. That was fine in the past. It isn't anymore. Supply chain disruptions, export risks, and component-level security concerns are now part of the conversation. And if you're building a sixth-generation aircraft or a hardened mobile command post, you can't rely on power tech that wasn't designed for your mission. Made in USA energy storage isn't just a slogan, it's a strategic asset. At American Lithium Energy, we've been working for years on battery cells that meet these exact needs, not just for space or commercial use, but for the most demanding military-grade applications. We produce cells right here in the US with 290, 350 watt-kg energy density, high discharge rates up to 100C, extreme thermal operating range, and advanced safety features like zero-volt technology and our SafeCore internal fuse system. We've supported aerospace integrators, drone OEMs, and system primes, and what they all need is the same: mission-ready energy, manufactured in America, backed by engineering that understands the fight. If you're working in aerospace, defense, or even advanced robotics, this is the time to rethink your energy design assumptions. The platforms of tomorrow are being built now. And whether you're developing ISR systems, UAV fleets, or ground-based launch assets, the batteries you integrate today will define the resilience of those systems tomorrow. Let's move from imported to integrated. From supply chain constrained to energy assured, I'm William Hadala. Thanks for watching Strategic Edge. If this resonates with the work you're doing, let's talk.